What's up, you guys? I am scared. I have been requested with this integral, and looks like the good old Canadian trick that a lot of you guys like, and I'm facing with more horrors now. Okay, we're gonna call the top one A, and we're gonna call the top one B. I mean, top one, the bottom one B. So, A. Is there a way I can simplify this? Let's see if I can simplify this even further without making it too nasty. Okay, maybe it's gonna be nasty either way, but okay. Well, where do I even start? Is the question. I don't even know where to begin with. I mean, we could. I lied, we couldn't. Do I want to do that? Actually, let's simplify this first. This is all square root of c plus s. And then we have like square root of c. This would be square root of c plus s. Plus square root of c. But then here we also have, this is also equal to, if we use Queen's rule, you get this. Right? And so if I, because they're both in a square root, right? If I add it together, c plus s plus c, square root of c, both of them are going to be like, you can't exactly add both of them. It's weird. It's like you have to, because they're both inside of a square root. So it's like, ugh, I don't want to do this actually. A squared is going to equal to this, 2c plus s, root c, and then plus 2 times, which is going to be, Alright, we're gonna retreat. We're gonna retreat everything. Okay. Well, shit. Okay. So, scratch that. Like, what the hell? What do I do? Like, what does this become? Because it doesn't really become anything nice. You just get this. Tangent of x all over 1 plus tangent of x. Now you don't really get anything out of it. Minus 1, which does absolutely nothing. Okay, because this is not even close. Wait a minute. Wait, tangent? Oh, no. I'm thinking about something else. Oh my god. That's so nasty. This is disgusting. What the hell? This is... I'm already struggling with the first integral here with I. And I have no idea. I don't even want to do this, because this is horrible, because then you end up with like things like this, and then you get things like this, and that's just wrong. That's just, you don't do that. You just don't do that. Oh, but then this one is t4 plus t5. And that's nasty. Okay. I'm so lost. Like what do I even like how do I even format this? This square root is bugging me. Like that's because you're literally, your integral is literally this. And it's so nasty. 1 plus square root of 1 plus tangent x. It's literally this. That's so disgusting. What the hell do you even do? Okay, so what happens if I do square root? Because I'm seeing this. This whole function is literally in terms of this. Oh god. Oh, I don't want to do this though. Oh, this is so nasty. Ugh. Oh my god, what did you give me? Oh god, this is some Romanian stuff. Like this is what a Romanian style integral looks like. Okay, so u square. Oh, I'm gonna throw up. Ugh. Oh. I don't know how I feel about this, mate. What on the tarnation is this? It doesn't get any better. It does not get any better at all. This is some nasty square technique, but like this. Oh my god, the radical. The radical does not. Because there's no way. I don't see how you can use beta here. Ooh, no, because this is from 0 to infinity. Oh my god! Ah! Okay. So, we might have to... Oh my god, why would you do this? If I use the inversion, does that do anything? If I let u equal 1 over x, does that look like the bottom? To me, no, because that bottom needs a minus 1. What the hell? What? Wait, but then this... Oh, wait a minute. That's very sus. Okay, because this... You can't even use Korean substitution either because the denominator is so... Oh my god. Right, this looks like Korean u-substitution, but even with Korean u-substitution, what are you going to do with the denominator? Right? Because you have this. Let u equal x plus 1. Sorry. Let u equals square root of x plus 1 plus square root of x. And 1 over u is equal to this. Right? Is that the technique to this? No, but that doesn't make any sense. What am I going to use this for? Okay, well, we're going to start all over. Ah, so is this where the trick kind of lean towards? Okay. Oh, well, this is gonna be scary. Wow. Okay. So it seems like I don't know if I want to. Do I want to turn everything in terms of theta over 2's? Do I want to do that? That's so scary. But we might actually have to do that. Disgusting. Theta. I don't know. I don't know how I feel about this. I don't know. I don't know. I genuinely don't know how I feel about this. This is... I don't know. I don't know. I don't know how I feel about this. I don't understand. I have no idea. Last thing in my mind is inverse jailbreak. Yeah, I don't understand how you would go about this. This is like... I was thinking about the, this identity. And I was thinking if I could turn that into like this, which was... But I don't think you can. Right, because this is y4 minus 2y squared plus 1. Right? Maybe it's some sort of, what, y squared minus 2 plus 1. But obviously we don't have that, right? That's not what that is. Oh my god! I don't think I can solve this at all whatsoever. Yeah, I can't. I have no ideas. I genuinely don't know how to solve this. Yeah, I'm sorry. But that's as much as I can do. Yeah. If you know the solutions, I would love to see how to quickly approach this. Like, what's the fastest method to actually compute this? But unfortunately, I can't find a fast way to solve this problem. So I apologize, but unfortunately I don't have the I don't know what else I can do with this integral. Oh my god. I decided to search up the solution because I couldn't freaking find a way to solve this elementary. And then, of course, I know my boy Quanto came around and freaking came up with the slickest solution. And I'm about to show you guys how Quanto solved this. I am just mind blown. I would have never ever thought of this in my entire life. So pretty much we're gonna do, so it's kind of the same, it's not exactly the same, but we are doing the Canadian trick, but we're gonna pull a doppelganger. Doppelganger? I forgot how it's spelled. But so you want to solve for ij, obviously, right? But notice how similar they are, okay? This is what I call a doppelganger, right? They're not exactly the same, but they're very similar, and they're only like a different by like a sign, okay? And the doppelganger trick is when you have something like a surd, like this, right? Something like this, right? Where this is I, this is the integral I, and this is the integral j, and you add them up together, okay? So you add them up together and you get something very simple, alright? And then you do the same thing for I minus j, and they also end up getting something simple. And then all of a sudden you're able to, oh, well, I is equal to, well, what is I? You just let 2y over 2? I'm sorry, this should be like something else, like t. Then this would be like y plus t over 2, right? Because what you're doing is you're literally solving for I by using a doppelganger. I don't know why I write a line across, but I minus j, right? And then you add it and you get 2i, right? Whatever y is, whatever t is, y and t are simple integrals that you can compute. And so I, the integral, is y plus t over 2. This is like the doppelganger, T2's doppelganger trick. But it's not exactly that though. It's kind of. What we're doing is instead we're going to do a zero substitution, 1 plus I over j minus 1. And the reason why we're doing this is because look at this. Now we have I minus j. So I minus j over j. And apparently I minus j has a form of something times j, which I would have never thought, okay? Because who would have came up with this? I have no motivation of thinking about this, okay? I would have never thought about this. So now let's go ahead and get right into it. This is now equal to 1. Well, actually, no, I'm sorry. No. First off, what is I minus j? What is I minus j? What the hell is I minus j? So, what we have, from 0 pi over 2, is we have the fourth root of 1 plus tangent of x, right? And then now we have what? We have 1 plus t. I'm gonna abbreviate it as t. T is tangent of x. I'm just gonna abbreviate it. And then we have minus 1 plus t minus 1. Okay? Now this here, I'm going to call this n. And then if you n square it, we get like 2 times 1 plus square root of 1 plus tangent of x. And then we also get plus 1 minus 1. Yeah, that sounds right. And then minus 2 square root of 1 plus t minus 1. So we get t, just t. Yeah? Does that look correct? And so now we have n equal to the square root of 2 times the square root of 1 plus t minus root t. Right? And so now this is equal to pi over 2 root 2 times square root of, this is fourth root, right? There's 1 plus t. And then we have 1 plus t minus t. But wait a minute. Look at this. This is root 2 1 minus 1 plus cotangent of x, right? However, by Queen's rule, you guys, by Queen's rule, let u equal pi over 2 minus x. What is this? I would have never guessed this. I would have never thought of this. I would have never, ever thought of this. This is literally square root times j. Literally this. So our answer here is 1 plus root 2 of j over j. So our answer, I over j, this whole problem is equal to 1 plus square root of 2. Oh my god. I would have never, ever came up with this. This is just crazy. Holy hell. Shoutouts to Quanto. Quanto came up with this solution, and I was just like, wow. I would have. This here is so sneaky. I would have never, ever thought of this. This is so sneaky. Holy hell. All right, that was amazing. That was very cool. Yeah, I hope you guys enjoyed that. I hope it was helpful. Thank you so much for watching, and I'll see you guys in the next video.